All right, guys. So we are going to start the next section today. Honestly, the reason I'm going ahead and moving forward because it shouldn't be too hard of a section, even for those who are not here. Okay. So we're looking at this whole chapter is about graphing. So we're going to be graphing lines, graphing inequalities, that kind of stuff in this chapter. So for today, we're going to graph linear equations by creating a table of values, so like an XY table, which I'm sure you guys have done before. And we're going to graph by finding intercepts. That one you may or may not have done before. Okay. All right, so first of all, though, consider the equation 3x plus 2 equals 8. How many answers will that have? One, right? You can solve that and find the answer. What would the answer be? It'd be x equals 2. Good. Right? Subtract 2 and then divide by 3. So that has one answer, right? What about y equals 2x plus 1? How many answers does it have? Right, so how many answers does it have? It's infinite. It is infinite. Stop, Aaron. Because, guys, if you graph that, what's it going to look like? It's going to be a line. Do you guys know what a line stands for? Every point on that line is an answer. So it's pretty much like you took a whole bunch of points, so many points that it makes it look like a line. So every single point that line passes through is an answer. It's an ordered pair. That's an x and a y. That's going to work. So it's an x and a y. If I plugged them in here, you get this would make sense. It'd be true. Okay. So how do you show your answers when you have an x and a y? Ordered pairs, guys. Ordered pairs. So it's an x and then comma and then y. Now, obviously, if that has an infinite number of answers, you can't list all of them for me. But if I'm like, hey, give me 3 answers to this, you could list 3 ordered pairs. They're just points on the line. Any point on that line is going to be an answer. Yep. So determine whether 3, 7 is a solution of that. Is that point on the line? How do I tell? Just plug them in. Just plug them in. Remember, it's x and then y. So my y is 7 equals 2 times 3 plus 1. Yeah, 2 times 3 is 6 plus 1 is 7. So 7 equals 7, right? That's true. So yes, that is a point on the line. If you would graph that line, that point would show up on it. What about negative 2, 3? Is that a solution of 2y equals 4x minus 8? But again, to check x, y, so I have 2 times 3 equals 4 times negative 2 minus 8. So that's 6, and that's negative 16. Does 6 equal negative 16? No. So that is not a solution. That is not a point on the line. Okay. Another way I can kind of ask this question, instead of just determine if it's a solution, I might ask, does this point fall on the line? In other words, if I plug it in, does it work? Is it something that's part of that? Okay. All right, so how do you find your own solutions? Like, I gave you 2 and asked you, but if I'm like, hey, give me 3 answers for this, how would you figure that out? Tap on the board, make it tell you. All right, first you want to solve that equation for y. This is why, again, we were practicing in the last chapter solving for literal equations, getting used to rewriting them for different variables. Solving for y is going to make my job a lot easier here. Then I can substitute any value for x and then just evaluate it, see what it equals. Anything I want for x. I can plug in 0. I can plug in 3. I can plug in negative 506. It does not matter. Because what do we know about lines? Once I graph them, what do you put on the ends of lines? Arrows, because what happens to those lines? Yeah, they go on forever and ever and ever. So I could pick any point I want. Eventually, it's going to fall in that line somewhere, right? All right, then I can substitute in. I'll evaluate that, and it'll tell me what y is. The solutions are points on a graph. So then I can just plot some points and connect them with a line, and now I have graphed that line. Okay. So as long as I know a couple points, I can graph a line. I can figure that out. Do you guys remember doing this at some point? Making XY tables, plotting points? Good. And then that graph should be a straight line. These are called linear equations. Because eventually we'll get into quadratic equations, which are x squareds. These will all be linear, because look at the first 4 letters of the word linear. What's it say? Line. They're going to make a straight line. Okay? So that's how I always remember linear means it's a straight line. It's like line near. Okay? All right, we doing okay? No one's going to yell at me if I push the button. All right, so let's go ahead and practice some graphing. So graph using a table of values. So what was the first thing we're supposed to do with that equation? I'm supposed to, oh, okay. I'm solving for x, right? Or solving for y. So we'll add 4x. Now be careful when you write it on the other side that you line up the like terms. Okay, so I have 3 plus 2x. All right, y is by itself. Then we will go ahead and make an xy table. And we can plug in anything we want for x. I'll be honest, most students stick to just a few certain points to keep it on the graph, because right, that graph only goes from -10 to 10. It's only so big. And I like to see typically what it's doing on the negatives as well as what it's doing on the positive. So most students will go -2, -1, 0, 1, 2. That's typically where we go. That way we can look at some zero or negative numbers right at 0, and then we can see some positives. And then all we're doing is plugging it in. You guys got a calculator? If you don't, grab a calculator. Let's just make this easy on ourselves. We're just going to plug them in. So if I plug in a -2, I'm going to type in 3 plus 2 times -2. And what do we get? That's -1. Okay, plug in a -1. So 3 plus 2 times -1. That's 1. Plug in a 0. 3 plus 2 times 0. Plug in a 1. 3 times 2 plus 1. Or 3 plus 2 times 1. Good, that's 5. And plug in a 2. And that is 7. Now, if you are using the graphing calculators, you guys know that you can just bring up that equation again and arrow back and change a number. Do you guys know how to do that? If you don't know how to do that, come ask me and I'll show you, but it sounds like most of you know how to do that. All right, so once you have your table, all we have to do is plot these. We just found points. So -2, -1. We're going to go back 2 and down 1. -1, 1. So back 1, up 1. 0, 3. So right on the line, go up 3. 1, 5. And 2, 7. And then we are just going to play connect the dots and connect those. Now, one thing about your graphs. What do you notice about the line I made versus my dots? Did I just draw it through my dots and stop? No. Go ahead and extend that. Now, if you're somebody who's a little OCD and you want to make every point all the way through the graph, could you do that? Yeah, you could. You don't have to, but you could. All right, so for me, guys, plot your points that you make, draw that line all the way through, and then put arrows on the end. If you don't have arrows, it is incorrect, because that line does keep going. All right, I could put anything I want in that for x. I'm going to get a y value back, and I could plot that point. Is this coming back to us? Yeah, awesome. See, today's not too bad of a day. That's not bad. All right, number 2. 2y minus 4 equals 4x. What do I have to do first? Good. Add 4. Are those like terms over there? Nope. So 2y equals 4x plus 4. And I divide everything by 2. So 4x divided by 2 is 2x, and that would be plus 2. All right, what do I do next? Draw my table. It's x, y, and again, I'm going to go -2, -1, 0, 1, 2. I'll plug it in and see what we get. So I plug in a -2. 2 times -2 plus 2. Good. If I plug in a -1, if I plug in a 0, if I plug in a 1, and if I plug in a 2. Whoops. I hit the bottom bar and it put it back. All right. 6. All right. So we just need to plot our points. So -2, -2, -1, 0, 0, 2, 1, 2, no, sorry, 1, 4, and 2, 6. Should you be able to tell if you did your math wrong on one of them? Or you plotted one of them wrong? Yeah, if they're not all in a row making a straight line, something messed up somewhere. Okay. All right, why don't you guys try? No, actually, no. Let's do this one together. I forgot this one changes a little bit. So solving this one for y, what do we do first? What do we do first? Good. Subtract the x. Are those like terms? Nope. So -3y equals -x plus 6. If you can, I would try to get in the habit of putting the x first and then the number. And then to get y by itself, good. Don't lose that negative sign because that's going to affect a lot of our problem. So y equals, what is -x over -3? That's 1/3, right? There's like a 1 here. So 1/3 x. I would like you to kind of see, when you have a fraction like that, just kind of throw the number in front and then your x. It's going to make things easier as we move forward. And then that's -2. All right, so if I go to make my xy table, do you notice the hint I put at the top? Use numbers that will cancel with the denominator. -2, -1, 0, 1, 2, I can do it. They're on the graph. They're just not pretty. So what would cancel with a 3? A 3? So I might go -3. What else would cancel with it? In other words, what can you divide by 3 nicely? 6. I may go -6, -3. 0 still works, right? And then 3 and 6. Yeah. So like if my denominator was a 2, I might go -4, -2, 0, 2, 4. What if it was a 5? What would you use? If it was a 5? If your denominator was a 5, what numbers would you plug in? 5, 10, a -5, a -10. Okay. Just want to make sure that we're kind of understanding that process. Just you multiply by something that divides nicely by that. That way it gets rid of all those ugly fractions or decimals. All right. So if I plug in a -6, 1/3 times -6 minus 2. Good. That's -4. See, it helps me to avoid fractions here because it's harder to graph a fraction. If I plug in a -3, yes. Sorry, I mean, when you said -1, I'm like, no, that's not right. All right, if I plug in a 0, that's just -2. If I plug in a 3, oops, and if I plug in a 6, that's 0. Also, did you notice I had a pattern going here? Yeah. Have you noticed that on all of these? If you have a pattern going for your x's, right, I have a pattern going, you should also have a pattern for your y's. That should be consistent. All right. So let's plot our points. -6, -4. -3, -3. 0, -2. 3, -1. And 6, 0. Darian, you still with me? I lost him for a minute. He was just in another world. All right, are we doing okay though, process-wise? Hi, my one delay student. There you go. Thanks. All right, let's go ahead and look at number 4. Why don't you guys try number 4 on your own? Okay, I'll work it out up here. You guys work it out on your own, and then we'll just kind of check. Okay, so do your thing. I'll do my thing. What about y equals 7? Y is already by itself, right? Okay, so if I would do an xy table, and let's say I'm plugging in -2, -1, 0, 1, 2, what's y equal? It literally says y is 7, right? So y is 7, y is 7, y is 7, y is 7, y is 7. Every single time, y equals 7. So when I plot my points, what really is happening here? Yep, it's just going to be a horizontal line. And people always confuse themselves on when they're horizontal lines versus vertical lines. But if you think about making your xy table, doesn't matter what x is, y equals 7, y equals 7, it's just always y is 7. Nothing changes that. So I could put in anything I want for x, and y is still 7 every single time. So what about the next one? Yeah, this one's x equals -4. So slightly different. Instead of my y value being always the same, now x is -4, -4, -4, -4. So does it matter what I put in for y? No, it doesn't matter. I can go ahead and plug my numbers in I want there, but x is -4. So then if I look at that idea, -4, x is always -4 no matter what. So that one's going to make a vertical line. Those should be the easiest graphing ones. I will tell you right now, they'll be the most missed. Because people just like, wait, I don't know what to plug in. Like they suddenly panic on what to do with those. okay? So if it's just x equals a number or y equals a number, you know it's just a straight line. It's either horizontal or it's vertical.
So should you use -0 in that case?
You can. But you'd be plugging in for y on that one, right? Because x has to be -4.
It doesn't matter what you use.
Does not matter. Yep, doesn't matter. Just so we're recognizing this means no matter what, it's always -4. So if you kind of make that table and plug those in, you're like, oh yeah, so it doesn't matter, then I can just plot those points and I can see what it's doing. All right, questions on the y equals and the x equal ones? All right. So the other way I wanted to look at graphing today is by your intercepts. What's it mean to intercept? It means to cross over. Like I always think about football. If somebody intercepts the football, they've crossed over the path of that ball and they've caught the ball, right? So same thing here. The x-intercept is a point where the graph crosses the x-axis. And then the point where it crosses the y-axis is the y-intercept. So if you know where it crosses the x-axis and you know where it crosses the y-axis, that'll give me 2 points, right? Could I connect those and make a graph? Sure could. These are like the easiest ones for me that I like graphing by this method because it's usually pretty quick. So to do this, you have to find the x-intercept by plugging 0 into the y-coordinate. Right, because think about where is it, when it's crossing this axis, what's your y value? It's 0, so that way it falls right on there. Okay, and then to find the y-intercept, where is it crossing this line? Well, what's your x value got to be? It's got to be 0, right? That way it doesn't move away from that axis. Right? So you'll just plot those 2 intercepts, draw a line that goes right through them. So these ones, I really like these. These should be pretty quick, especially if your basic math skills are really good. Because this is one thing, guys, when you're doing intercepts, do not solve for y. You make your world actually harder by solving for y. So for me, when I'm like intercepts, my brain sees intercepts right away. I go 0, comma, I don't know, and I don't know, comma, 0. That is the first thing I always write when it's like solve by graph by intercepts. I know I got to plug 0 in for x. I have to plug a 0 in for y and see what I get. Because look what happens. If I plug 0, remember this is x, this is y. If I plug 0 in for x, what happens to this piece? It's nothing, right? That's gone. So if I have, oops, if I have 3y equals -12, y is -4. Right? Putting a 0 here gives me just 3y equals -12. Divide by 3. So that's where I got y is -4. Okay, what if I plug a 0 in for y? Then I get 4x equals -12. Oops. Divide by 4, and that's -3. Do you see where like this could be pretty quick, right? Just plug in a 0, cover that part, solve it. 0 for the other one, cover that up, solve it. And if you can do that in your head, by all means, do that in your head. So let's just plot them. So 0, -4 is just down 4. And -3, 0 is just back 3. Look at that. I can graph this. Graphed. So for me, if I'm given an option to graph, and they're like, hey, go ahead and graph this, and I see I have like the x and y on one side together, I always go intercepts. Because I'm like, cover up one, solve, cover up the other, solve, done. Super fast. Could I solve this for y and actually like put an xy table and do it that way? Yeah, I can. Absolutely, I could. But I don't have to. Yeah, I don't have to. Why would you? Yeah, lazy mathematician says that's faster. All right. Graph by the intercepts. So again, in my brain, I'm writing down my 2 ordered pairs where 0 is an x and the other one 0 is a y, and I'm going to go ahead and plug those in and see what I get. So again, if I put a 0 in for x, that part's gone, and I have 2y equals -6. Good, so y is -3. What? It just because of the numbers that are used. 2 times 3 is 6. So just the numbers. If I plug in 0 in for y, Be careful, that's going to give you 0 equals 3x minus 6. So I'd have to add 6. Good, so we know x equals then is 2. Questions on intercepts so far? For me, I always think they're super easy. Then I always have students who are like, I don't know what you're doing. So please tell me if like you're not getting it, okay? So I'll just plot those 0, negative 3, so down 3. 2, 0 is just over 2. And draw my line. I have an x. If you have no x and it's just a y, what do we know about y equals? That y value is always going to be the same, right? So it's just going to be that. It's going to be that horizontal line. Yeah, I won't ask you to use intercepts if it's just y equals a number or x equals a number. For those, it's better to look at a table and kind of think through that. All right, so this one, again, intercepts. I'm going to set up my ordered pairs with my zeros, plug them in, and see what I get. So 0 for x, that's going to give me 4y plus 2 equals 0. So subtract 2. 4y equals negative 2. Oh, be careful. What is negative 2 over 4? It's negative half. If I have 2 cookies and give them to 4 people, you're only going to have a cookie. All right, so that's negative half. All right, and then if I'm doing 0 in for y, I like that one, right? It's just 2 equals x. So that's 2. Can you plot 0, negative half? Yeah. Yeah, it's just halfway in between, right? So I'm just going to go down half. And then 2, 0. Oh, that's a terrible angle. There we go. Nice non-curvy line, right? My lines are terrible. Now, guys, honestly, for me, graphing is one of those things. It's great to see the graph, kind of see what's going on. Are graphs exact when you draw them by hand? No. So if I wanted you to do exact work on graphs, we would be using probably Desmos, if you guys have ever used Desmos before. And we will use that later on in this chapter too. Okay, we'll get into Desmos and look and see how that works. Questions on graphing with the table or graphing with intercepts? How do you tell if a point is on the line? Without drawing the line. What if I say, here's the equation, is this point on the line? Just plug it in. Yeah, see if it works or not.